Okay, so Daredevil launched out of the cannon, so I'm going to draw a cannon. There we go. Killer cannon, there we go. Here's a Daredevil launched out. Okay, going to travel a curved path through the air. And it tells us that we have a velocity of 17.5 meters per second, and that it's launched at an angle of 35 degrees. Okay, so that's what my picture looks like. Got the object, got the angles and the velocity given the things that are given, and I've got the motion that it's going to travel. So then I need to set up my X and my Y chart. Okay, so there's only two numbers that are given to me, and that is the 17.5 and the 35. So I got to figure out, do those go in the X or do they go in the Y? I've got bad news. They don't go in either. Because 35 is an angle, so it's not an X or a Y. It's some combination. And 17.5 is at an angle, so it's not X and it's not Y. X is only forward or backwards. Y is only up or down, and this is neither. It's forwards and it's up and down. Okay, so I do know that acceleration is 9.8. However, because I'm starting going up and going right, A is going to be a negative 9.8 this time. And that's because we always call forward positive. So forward is right and up. So A, the acceleration, G is always down. And so because it's down, it's negative. Now, remember, on the front page, we also had acceleration down, but the difference is the motion was down. That's why we made it positive. So a little bit of a different situation here just to be careful of. And yes, it does matter. Okay, that's all I can do. I can't do anything else. That's as far as I can get, so I'm just going to keep going. All right, find the X and the Y components of the Daredevil's initial velocity. So here's the velocity that I have. Launched at an angle of 35 degrees, got a velocity of 17.5 meters per second. Okay, so I need to find the components, which would be the X, which is A, and the Y, which is B. So, how do I solve those? Well, if I look at my equations on the front side, we've been solving for C using Pythagorean theorem. We solve for theta using tangent. We're going to solve for A using cosine and B using sine. So, I just need to set up A equals C. Now remember, C is the angled one. So, C cos theta, and B is C sine theta. Okay? So, plug those things in, figure out what the cosine of 35 is, multiply that by 17.5, and you're going to get 14.3 for A. And sine of 35 times 17.5, you're going to get 10.0. Okay, any questions on B?
How'd you plug it in the calculator?
I'll show you. So there's two different ways of doing it. It just depends on what calculator you got. So on this type of calculator, you would do the angle first. So you would do 35 cosine first, and then you would multiply that by 17.5. Oh, 17.5. Okay. On the other one, you would put the value first, so 17.5 times cosine 35. And you get that. So it just depends on what kind of calculator you have. If you're not sure, ask me and I'll show you how. Okay? All right, so we got those two numbers there. So now we need to know, and let's go ahead and put those in the chart. So the A is the x velocity, 14.3. The B is the y velocity, but it's specifically the y velocity at the beginning when he's launched. So its VI is 10. Okay, C wants to know the max height that she'll reach. So what's the max height of this daredevil? That's going to be D. Specifically, D for the y direction. So I'm looking for D in the y direction, but I'm in a pickle because this is not enough information to solve. So I need to know something else. Is there something else that I know specifically for the max height? I'll give you a hint, there is. What do we remember? I know it was a long time before Greek. Doggy. Yes. VF is 0. Now, this is only true for the maximum height. It's not true anywhere else. It's only true for the maximum height. Okay? So, because we're solving for the max height, we can say this. So, we need an equation that's got A, VI, D, and VF. A, VI, D, VF is ain't got no time. So, VF squared plus VI squared plus 2A, remember A is negative 9.8 this time, D. Sorry, this should be an equals, not a plus. So 0 equals 100 minus 19.6 D. We cannot subtract these two because this has D and this does not. So we got to get the 100 to the other side. God bless you. So negative 100 equals negative 19.6 D. So then we divide that to both sides. And we get D equals 5.10. All right. Any questions there for me? All right. Good. Cruising. D, how long will it take to reach the max height? That one's pretty straightforward. How long is time? How long will it take, I guess I should say, is time. So we're just solving for T. We're going to keep using the y direction here. I'll add in my D value, 5.10. There's two equations that have T in it for the y direction, and that is Big Chalupa and Old Faithful. If you can use Old Faithful, you should. It's easier. We can use it. We know VF, we know VI, we know A. So VF equals VI plus A T. Again, we can't combine these because this has a T and this does not. So minus 10 to both sides get negative 10 equals negative 9.8t. Divide the negative 9.8 to both sides. And we got t to be 1.02. Okay, almost done. What's the total horizontal, God bless you, displacement, God bless you, the daredevil will travel before hitting the ground? Okay, so total horizontal displacement, that's dx. So there's only one equation for the x direction, that's v equals d over t. Okay, so we're solving for dx. What's my time going to be? Say again? How'd you get 2.04? Because we found 1.02, so where'd you get the 2.04 from? Yes, this is the time to get to here, to get to the max height. But I need to know how long it takes to go the whole way. So the time we're going to use for the x is not 1.02. The time we're going to use for the x is the 2.04. That's specific to this type of problem. We didn't have to do that on this type of problem because we started at the top and went down. So the time to go down and the time to go forward, they're the same time. On this one, the time to go up is not the same as the time to go forward because the time to go forward is going up and down, not just up. So we found the time to go to the highest point. Now we need to use the time to go the whole way. So v equals d over t. We're using the x velocity. We're not using the y velocity. We're not using the total velocity. We're using x. So v equals d over t. Multiply the 2.04 to both sides. And you end up with d to be 29.17 meters. You might be off a little bit. Rounding will make things a little bit different, but it should be fairly consistent as long as you're doing the right work. Okay, any questions for me on how I set this up, how I solved this, what I did, any of that kind of stuff?